Hi everyone and welcome to the new video. This is the second part of my review of the Seed Studio SenseCAP Solar Node P1-Pro. This node is interesting for several reasons. It's fully autonomous, it has a 5-watt solar panel and a battery inside. Out of the box, SenseCAP Solar Node is ready for the outdoors installation. For example, it can be installed on the roof. It does not need any power, which is important because you don't want to drill extra holes in your wall. But as I will show in this video, you can also use P1-Pro node indoors, it will work as well. So you can just use it as a standard Meshtastic node, and as a bonus for emergency communication, it will work even if the power is down. As a disclaimer, this node was sent to me by OpenELAB. OpenELAB is a web shop, it has a wide variety of Meshtastic products and also other cool products as well, like sensors, DIY and so on. Just keep in mind that this review is independent, it's not a paid advertisement. If you want to buy this node for yourself, the links are added in the video description below. And now let's start with the test. In this video I will show how to perform a range test and we will compare two different boards. I will also show my solar panel statistics and I will also show how we can upgrade this node. Let's get into it. And first let's start with the range test. A range test is a cool feature of Meshtastic, and why it is important? Well, if you have different nodes or different antennas, you can run a range test and see what the real range will be. For example, I have this TTGo board that I used before, and it works well. It allowed me to get about 1 kilometer range. And this P1-Pro node definitely has a better antenna, but what will be the real difference? To answer this question, I can just run a range test and see a result. Let's do it. Doing a range test is generally simple, but it requires some steps. First, I need to open the board settings, go to channels, select the primary long fast channel and set the location. Here you can change the accuracy, because by default the accuracy is about 1 mile, which is too big. With the default precision of 1 mile, you will just see no points on the map. As you can see, in my case it's set to 300 feet, which is good enough. Optionally, if your node doesn't have a GPS, you can go to device configuration and set the position. You don't need to have a physical GPS, you can just enter the coordinates. Then you go to the module configuration, and here you can select the range test. So here I am enabling the range test on the P1-Pro node, and I will set the interval to 1 minute. Now I can press save and the node will be restarted. And after that, the P1-Pro node will start sending range test messages every minute. They are disabled by default, so they will not disturb other people. And now I need to enable range test on my second board. As a second board, I will use Heltec V4. I will take it with me and it will be my receiver. The log will be collected by the Android app and I will show later how to analyze it. But first I need to enable the range test on the Heltec board as well. But on the receiver board, I don't need to enable sending the messages, it will only receive. In the same way as before, I need to go to channel settings and I need to set the location accuracy. Optionally, you can also enable the precise location, which makes sense if you are walking with the node. And now I can open the main channel and I can see the messages. Important thing is that the range test is disabled by default, so it doesn't disturb other people. And now I'm ready to go for the walk. Okay, now I returned back and I can show how I can analyze the data. First I need to open the Meshtastic app. Then I scroll down and select Export All Packets. Then I need to save the file on my PC. This is just a standard CSV file that looks like this. In this file you need to keep only the header and the range test packets, other data you don't need. Then you can open Google My Maps. Here I'm selecting create a new map. I can name it something like P1-Pro test. Then I'm importing file I saved. And here the UI is simple. First I'm selecting the receiver latitude, and this will be my latitude. I'm selecting the receiver longitude, and this will be my longitude. And as a title I will select a distance. And here is the result. And as we can see, the result is interesting. I live in Amsterdam and I was walking in this area. And the result is really interesting and it surprised me. In my previous test, I used the TTGo node that you see on the video, and the distance was exactly like this. This P1-Pro node has definitely a better antenna, it has higher gain, so the signal will be a bit stronger. But interestingly, the result is mostly the same, and most of points are here. Most of the points are exactly the same, and the distance is a bit higher than 1 kilometer. As we can see, it's 1.2 kilometers. But surprisingly, one of the nodes got extremely far compared to others, and the distance was 2 kilometers. So technically, as we can see on the screen, most of the points are located in this area, but because of the antenna with a better gain, one signal somehow managed to travel almost twice distance. So as we can see, this antenna is good, it's better than on the previous node, and it is obviously bigger and it has a higher gain. But of course it happens only once. I got only one packet from such a distance, so it's not reliable, because I think in the city it mostly depends on the line of sight and the radio signal is blocked by the building. Still, it's interesting to see that the better antenna allowed me to get the longer distance, practically twice longer. So to summarize this test result, I think this P1-Pro node has a good antenna with a good performance and I like it. And now let's go forward. Earlier in this video I promised to show my long-term solar panel performance, and I think now it is time to do this. But first I want to talk a bit about the mount. As we can see from this box, a SenseCAP Solar Node is designed to be mounted on the pole or on the wall. As we saw from the unboxing, there are special brackets and connectors included. However, the challenge for me is that I live in the city and I don't have a pole nearby, I don't have access to the roof. And I also don't want to drill my wall to put this node. So as you saw from the video, I just decided to keep it on my window and it works fine. It's even better for the test, because indoors the sky view is limited, so during the day I have less sunlight. And practically if you put your SenseCAP node outdoors, it will get more electricity than I got. As for the solar power itself, I have no problems with that. I can open the node, I can scroll down and select device metrics. Now the SenseCAP node is running for 2 weeks, and as we can see during last week, the battery level is not going lower than 95%, so practically it is always charged. I think it's a good result for the window installation, but just keep in mind that now it is summertime for me, and depending on the month and your location, the solar installation can be different. For example, if you live in Norway and it is winter, the solar panel performance will be definitely lower. Still, at least for the current installation, I think it's a good result and I'm happy with that. And now let's go forward and I will show you how you can easily upgrade this node. In the comments section for the previous video, one of the viewers mentioned that the SenseCAP Solar Node has a port for an external sensor. I checked the manual and it is indeed true. SenseCAP node has a standard port for the E2C bus, and Meshtastic has an internal support for the big variety of sensors. You can see the list on your screen, and as you can see it is pretty big. In the Seed Studio page, the sensor port is called Groove, but practically it's just a standard E2C bus. You can easily find the pinout online, it looks like this. I did an order on Amazon for the Beam E280 sensor. As you can see on the screen, the cost is about $13 for 2 items, so it's about $6–7 per item. And for this price you get a sensor not only for the temperature but also for atmospheric pressure and for humidity, which is nice. And I also have found a proper cable in my box. I actually don't know when did I buy it. It was an old one, but it does the job. I soldered this cable. Obviously during the soldering you must check that the pinout is correct. And when it's done we can connect the cable and turn on the node. As a next step you must open the Meshtastic app, go to the telemetry settings and enable the environmental metrics module. The Meshtastic app is smart enough. It will scan the E2C bus and automatically find the proper sensor. You don't need to do anything. And after that the node will be restarted, and after some time you can see the new data. And as we can see, there is an atmospheric pressure here. I also can see humidity. I am making this video during the summertime. It was a heat wave and the temperature inside is 32 degrees, so it's pretty hot. Obviously, the next question is how you can put these sensors inside the node, because the box is sealed, and if you close these, the temperature, humidity and pressure may be incorrect. However, as you can see, there is a port at the right. You can drill a hole here, fix the wires with a hot glue or something like this. The case is made from plastic, so it should be easy. As for me, I am running the node on the window, so I just decided not to close the box. In this case, the pressure and humidity will be more or less accurate. And as a bonus, you can open the Meshtastic app, go to telemetry and see the graph for several days. For example, it is interesting to see how the atmospheric pressure is changing or humidity. It is nice to see the graph. And if you're going to install the node outdoors, probably you can find the professional sensor kit with the proper waterproof housing. Alternatively, you can make a DIY solution. It is part of fun, right? And now let's make a short summary. As a general impression, I like this SenseCAP Solar Node and it works well. It has a good antenna, it has a 5-watt solar panel. The node has internal battery, it can work autonomously and even can be used for the emergency communication. As a disadvantage for me, I would prefer this node to have a stand for the indoor mount. This mounting bracket is kind of okay to be used in the barn, but for the home installation it just doesn't look attractive. Not everyone has access to the roof nowadays, and lots of people live in the cities, so I hope that Seed Studio can make an indoor version as well. But in general I like this node and it works well. Thanks OpenELAB for sending me this node. If you want to buy the same one, the links are added in the description below. I am planning to do more interesting Meshtastic tests. Feel free to press like and subscribe if you want to see future videos. Thanks for watching and see you next time.